Please, let's take a look at these Z transforms, okay, these sequences, and then find their respective Z transforms. So let's get into it. So the first one, I, x of n is equals to a exponent n into u of minus n, okay. So if you have a sequence like this, then you know that x of z is equals to, here is time reversal sequence, okay. The general formula is such that n is equals to minus infinity to what? Infinity. This is the general formula into what? Z of minus n. So here, with respect to this sequence, here is time reversal. So the sequence is starting from minus infinity to 0. Because n is equals to 0. So n is equals to minus what? Infinity to what? 0. And then you have a exponent n, u of what? Minus n. Okay. Into what? Z of minus what? N. So basically your sequence is like this. Okay. U of minus what? N. Okay. So here you have your what? N. So u of minus n means that here, 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 okay. And then it's going to what? Minus from minus infinity. Here is what? 0. So this is how your sequence is. So this is how your sequence will be like. So basically, you're going to have x of 0. So here, n is equals to minus what? Infinity 0. Here it is 1 because this place is what? 1. So because here is 1, then your sequence will now become z minus what? N. But it's difficult to work with these limits that you have here. So you have to change them. So to change them, let's say put n is equals to minus what? N. Okay. So now if you do that, then your sequence will now change to what? N is equals to what? 0. And your upper limit will become what? Infinity. Okay. And then you will have what? A exponent minus what? N. And z exponent what? N. Okay. That's what you have. Okay, so now when you have this one, then what you can say is that x of what? Z is now equals to what? Summation up to infinity from 0. Okay, you can say that a exponent minus 1 into what? Z. Okay, into z exponent what? N, which is basically equals to the expansion. Okay, if n is equals to 0, what do you get? You get 1. If n is equals to 1, what do you get? A exponent 1 what? Z. If n is equals to 2, what do you get? You get what? A exponent minus 1 what? Z into what? 2. Okay, and then it goes on to what? Infinity. Because it's from what? 0 to what? Infinity. So this is what you get. So if you have this one, you can say that let a exponent minus 1z is equal to what? X. Okay, so if you have this one, then you can say that 1 plus x plus what? X squared. Okay, plus, okay, it goes on to what? Infinity. And this is equals to this, this is equals to this binomial expansion. 1 minus x exponent minus what? 1. Which is your x of what? Z. Okay. Which is your x of z. So now, if you have that one, then your x of z is going to be equals to what? Here, you're going to have 1 over what? 1 minus what? X. But you know that your x is a exponent minus 1z. So 1, okay, over 1 minus a exponent minus 1 what? Z. If you should multiply through by a, you get a over a minus what? Z. Okay, you get a over a minus what? Z. Or you can say that if you should multiply through by minus 1 also, you get minus a over z minus what? A. And what will be your ROC? Your ROC is such that this summation will go to infinity if x is greater than 1. But if x is less than 1, then it will converge. So now here, x should be less than what? 1. So now, we know that x is what? X is basically a exponent minus 1z is less than what? 1. So z over what? A is less than what? 1. Okay, so that means that mod z is less than what? A. Okay, mod z is less than a. So now what we can see from here is that if we have a exponent n u of minus n, okay, and then you take the z transform of it, then you're supposed to have minus a over what? Z minus what? A. Okay, and then your ROC is supposed to be what? Less than a. Okay, so that is how you can actually solve the first one. Okay, now let's take a look at the second one. So I we are given x of n. Okay, x of n to be equals to what? 1 over 2n. Okay, into u of minus what? N. Okay, this is what we are given. Okay, so this is just like the first one that we just solved. Okay, so we can just imagine from the same approach to write the answer for this one. Okay, so now have 1 on 2 exponent what? N. U of minus n will therefore have a z transform, okay, of here minus a. Okay, so minus a, so minus 1 on 2, okay, over what? Z minus what? 1 on 2, and my z transform, okay, is supposed to be what? Less than what? 1 on 2. Okay, so basically this is what I am supposed to what? Have. Okay, this is what I'm supposed to have. Okay, so if I should multiply this, if I should multiply through this by 2, what do I get? Here will become minus 1. Okay, and then here will become 2. Here will become what? Minus 1. So if I should multiply through by 2, then I'm going to have what? Minus 1 over what? 2z. Okay, minus what? Minus 1. Okay, my ROC will remain as it is, less than what? 1 over 2. Okay, so basically this is how you can solve the second aspect also. So our third question is x of n is equals to 1 on 2 exponent n into u of minus n minus 2 exponent n into u of minus n minus 1. Okay, so this is what we have to solve. So basically this part, okay, this particular part is just like what we've done before in our earlier lectures. Minus a exponent what? U of what? Minus n minus what? 1. Okay, so if we have a sequence like this, how do we solve it? Okay, so what we can say is that we can bring this minus outside. Alright, so this one is time reversal and is from what? Minus infinity, and is equals to what? Minus infinity to what? To minus 1. Okay, because if you should actually sketch this sequence, then you will know that it's going to be like this. Okay, n is equals to 1. But the n is equals to 1 here is not going to be positive 1. It's going to be negative 1 because of this negative sign. So basically it will start from here. It will start from here, and then it will come here, and then it will come here, and then it will continue. So here is minus what? It's continuing to minus infinity. Minus 3, minus 2, minus 1. Here is what? N. And then here you have, here is what? 1. Here you have u of minus n minus what? 1. Okay, so that is how this sequence is going to be like. So we are coming from minus infinity to what? Minus 1. And this minus sorry, this minus sign here, this minus sign here, that is what I have brought here. This minus sign here, that's what I brought here. This sequence is what is giving us what this limits here. Okay. So now here, so it's from minus infinity to what? Minus 1. So minus infinity to what? Minus 1. Okay. And the value is 1. So the value is 1. So we can say that here, this, I've already brought this minus. This minus is the same as this minus, and I brought it here. So now I can say that A into what? N into U of minus N minus what? 1. Okay, but this is a unit step what? Sequence whose value is 1. Okay, here is Z minus N. Therefore, I will have what? Minus 1. Okay, minus out, minus 1. N is equals to minus what? Infinity. And then I have A exponent N and Z exponent minus N. This is what I have. Okay, this is what I have. So now, if I have this one, I have to change my limits here because it's difficult to deal with this one. So now let N equals minus what? N. If I do that, please, you will have to know that I'm trying to find the what? Z transform. So the Z transform is going to be equals, if I do that here, let me wait with my limit. So N here, if I do this, then here it's going to be minus N, and then here it's going to be what? Positive N. And then here it's going to change the limit, okay? Because I've changed here. So here it's going to be N is equals to 1, and here it's going to be what? Infinity. So now if I do this, then I can say that here infinity N is equals to 1, okay? A minus what? 1, okay? Into what? Z. Into Z exponent what? N. Okay, so I can say this one. Now, if I say this, then what I can also mean is that if I say this, what I can also mean is that I can expand this particular summation that I have here. If I put in 1, what will I have? I will have A minus 1, okay, into what? Into Z. If I put in 2, what will I get? I will have plus A minus 1 into what? Z, and here will be squared. If I put in what? 3, what will I get? I will get A minus 1 into what? Z, what? Cube, okay, plus it goes on to what? Infinity. It goes on to what? Infinity. So basically, these are some of the things that I can get with respect to this sequence, okay? So now, what I can actually do is that I can factorize out. So if I factorize out A minus 1Z, I'll get what? 1. Okay, and then I'll get plus A minus 1 what? Z. Okay, because A exponent minus 1 times A exponent minus 1 will give you A exponent minus 2. Here you get A exponent minus 2. Z exponent 1 times Z exponent 1, you get Z exponent what? 2, which is here, so it's the same. Okay, and then here I will get A minus 1Z, okay, all what? Squared. Okay, and then I'll get plus A exponent minus what? Okay, if there were a fourth term, then I'll get A exponent minus 1 or Z, okay, Z, or what? Cube, okay. Then actually it's going to what? Infinity. So basically, it's going to infinity. So I'll have A exponent minus 1 Z into what? 1 plus what? X plus what? S squared plus what? S cube, okay, plus what? Up to what? Infinity. Up to infinity. Okay, so now what I can do here is I can just say this particular sequence, okay, this particular sequence in this bracket, basically here minus 1 what? Z. In the sequence, please, you have to know that here is X of what? Z, and here is X of what? Z, and here is X of what? Z. Okay, so and this particular sequence here is what? Binomial expansion from this one, okay, minus 1. Okay, it's from this one. So now my X of what? Z is now equals to A exponent what? Minus 1Z over what? 1 minus what? 1 minus what? A exponent minus 1 what? Z. Okay, why? Because I said that A exponent minus 1Z is equals to what? X. Okay, see that here. A exponent minus 1Z, I put X. Okay, A exponent minus 1Z squared, X squared. A exponent minus 1Z, X cubed, X cubed. Okay, so that is why. Okay, so now if I have this one, then what I can do is that I can multiply through. I can multiply through by A. If I multiply through by A, please. There is something I have been omitting. Okay, I'm so sorry. You see that there was a minus here. Okay. You see that there was this minus, which I said is this minus, which I brought it here. Okay, and I brought it here. Okay. So now going forward, it has to come here. All right. It has to come here. All right. It has to come what? Here. All right. It has to come what? Here. All right. It has to come where? Here. All right. It has to come where? Here. All right. And it has to come here. Okay. It has to appear here. So if I should multiply through by A, then what I'm going to get is that I'm going to get minus Z, okay, over what? A, okay, minus what? Z, okay. So this is what I'm going to get. And what will be the Z transform for this particular sequence, okay? So the Z transform for this particular sequence is such that Z must be less than 1 before it can go to what? Infinity. So X must be less than 1, sorry. So now here, X must be less than what? 1. And I know that X is A exponent minus 1 what? Z must be less than what? 1. Okay, which should be what? Which should give us what? Here, Z over what? A should be less than what? 1. Okay, so which should give us what? Z should be less than what? A. So Z should be less than what? A. Alright, so this is how I can actually develop the formula to solve for this particular aspect. Okay, but you see this place, you see, if I multiply through by negative 1, if I should multiply through by negative 1 also, then actually it will become like this. It will become Z. Okay, if I should multiply here by negative 1, okay, it will become what? Z, negative 1 times negative Z, it will become what? Positive Z. And here, negative 1 times A, negative what? A. Negative 1 times Z, positive what? Z. So Z minus what? A. That's what I'll get, okay, if I should multiply through by negative 1. And then my ROC will become what? Mod Z is less than what? A. And now I can say that minus A into what? U of what? Minus N minus what? 1, okay, has this particular what? Z transform. Okay, has this particular Z transform. Now I will just apply this knowledge to the question that I am being given over here. Where is that question? To this particular what? Question. Not this part, okay, but this what? Particular part. Okay, so I'll just apply the knowledge to it. So if I apply the knowledge to it, then I'm going to have X of what? Z to be equals to, here I will just have Z, okay, I will just have Z over, I'll just have Z onto what I'm given here. Okay, first I will deal with this particular aspect, which is very simple to deal with. Okay, so to deal with this part, we just solved our previous question that we solved, was just like this one. Okay, was just like this one, whereby we got half over Z minus what? Half. Okay, and if we should simplify, then we're getting what? 1 over 1 minus what? 2Z. The question that we just solved, okay, was just like this one. So we just put that particular knowledge down here. So it's what? 1 over what? 1 minus 2Z. Okay, and this place, this is what we're getting. Okay, we're getting what? Z over what? z over z, okay, minus what? 2. Okay, z minus 2. That's what we're getting. Okay, so and then our ROCs. Our ROCs are what? Z here, we're going to have an ROC of Z, which is actually which is actually less than half. Okay, less than half. Okay, so here less than what? Half. And then here we're going to have an ROC, okay, which is what? Mod Z, which is also less than what? 2. Okay, which is less than 2. So now, if we should plot these two ROCs, okay, then what are we going to have? Okay, so now let's plot the one which is half before we plot the one which is 2. Okay, so now this is our Z plane. So here is imaginary of Z, and here is real of what? Z. Okay, so here is what? Z equals half. Okay, so here Z equals to what? Half. Okay, which is the radius. Okay, so for Z equals to half, is what? Less than Z is less than half. Z is less than half. If Z is less than half, then it's going to be within the circle. Okay, it's going to be within the circle. So now I'll shade within the circle. Now Z here 2. Okay, so let's plot that one also. 2. So here Z is equal to what? 2. It's also Z is less than 2. If Z is less than, then it's going to be what? Within the circle. Within the circle. Okay. Okay. If Z is greater than, then outside the circle. If Z is less than, then within the circle. So now if we see these two, where is our intersection? It's within what? Half. So then our final ROC, okay, so to draw the Z plane again, then imaginary of what? Z, and then real of what? Z. Okay, it's going to be what? It's going to be half. It's going to be Z equals to what? Half. And it's going to be what? Shading within what? This one. Okay, and our final ROC is going to be such as Z, okay, less than what? Half. Okay, so basically this is how you can finish this question. Okay, this is how you can finish this question. Now let's see the next one. Okay, so our next question, we are given that x, that is IV, x of n, okay, is equals to a mod n. Okay, a mod n. Whenever you see a mod n, that means that the mod here has to be taken for what? For the negative aspect, and then also for the positive what? Aspect. Okay, so let's say that for the positive aspect, okay, for the positive aspect, we're going to have x of n. Let's first write the general formula. So now x of n, okay, which is actually z of what? X of what? N, which is actually z of what? A mod what? N. Okay, is going to be equals to summation up to infinity, up to n is equals to minus infinity. Okay, x of what? N into z of minus what? N. Okay, which is actually equals to what? Z of what? Infinity. N is equals to minus what? Infinity. Okay, a mod n into z minus what? N. Okay, so this is the question that we have. Okay, so we will take the positive aspect, and then also we will take what? The negative aspect. Okay, the positive aspect and the negative aspect. Okay, so first, let's take the negative aspect. Okay, so if we take the negative aspect first, then we're going to have summation. For the negative aspect, n is going to come from what? Infinity. N is equals to minus what? Infinity. And it's going to go to what? It's going to go to here, place is what? A mod A less than, okay, less than 1. Okay, mod A less than 1. So that means that it's going to actually go from n from minus infinity to what? Minus 1. Okay, and then here I'm going to have A exponent what? Minus n to what? Minus n. So So this is the negative what? Aspect. Okay. So now if I have this, the negative aspect like this, then this one I can write it as what? Minus 1 here. Okay. N is equals to minus infinity. I can say that a minus what? 1 into z into z. Okay. Here exponent what? N. Okay. Now I can expand this particular summation I have here. Okay, so if I am expanding this summation, no, I shouldn't expand it now. Let me change my limit. Okay, so in that case, n is equals to minus what? N, to change my limit. Okay, now changing the limit here is going to, here is x of what? Z, because we're finding the full Z transform. Okay, so here, changing my limit here is going to give me, here is going to be infinity, n is equals to what? 1. And then here it's going to be what? A minus what? 1 into what? Z, exponent what? N. Okay, if I do that, then now I can insert my values. If A is minus 1, what will I get? I'll get A minus 1Z. Okay, plus if A is 2, I'll get what? I'll get A minus 1Z what? Squared. If A is 3, I'll get A minus 1Z what? Cube. And then it will continue up to what? Infinity. So now, if I should factor out something, then I'll say that A exponent minus Z, A minus 1Z, okay, will go into what? Will come out, and then I'll have 1. And I'll have plus what? A exponent minus Z, okay, like this. Okay, and I'll have what? A exponent minus Z what? Squared. And it will continue up to what? Infinity. Okay, it will continue up to infinity. Okay, so now this is what I will have. But I know that in this case, I can say that A exponent minus 1Z, okay, here is 1. I can say that here, this place will become what? X. Here will become what? S squared plus up to what? Infinity. And I know that whenever I have something like this, A exponent minus 1Z, this series is from the expansion of this binomial expression, okay, minus 1. Okay, so now my x of what? Z is equals to this. Okay, so now if my Z of x is equals to this one, then what I can say here is that I can have A exponent minus 1Z, okay, over what? Over 1 minus what? A exponent minus what? 1, okay, Z. I can have this one. Okay, so now if I can have this one, then what I can do is that I can just say that A exponent Z, if I should multiply through by A, I'm going to have Z over A minus Z. Alright, so that is what I am going to actually have. Okay, I'm going to actually have. Alright, so now I can now deal with the next section of it. So from here, I can also say that if I multiply through by minus 1, I'll have what? Minus Z over what? Z minus what? A. And my ROC will be what? Z should be greater. What? ROC should be such that X is what? Less than what? A. Okay. X should be less, sorry. X should be less than 1. X should be less than 1 before this summation can convert. If it's greater than 1, it will not convert. So X should be less than 1. Okay, if X should be less than 1, then what I can say is that if X should be less than 1, then what it means is that Z over what? A should be less than 1. So what it means is that A, okay, A should go here. So Z should be less than what? A. So it should be less than what? A. Alright, so that's what I can say here. Now, let me go to the second aspect. What is the second aspect? Okay, the second aspect is such that AN is positive. Okay, so in that place, I'm going to have X of what? Z is going to be equals to what? Summation, okay, basically from 1 to what? Same infinity, okay, and then, but here AN is positive, Z minus N, okay, this is what I'm going to have. So if I have this one, then basically it's going to be what? This like this, okay, and then I'm going to have AN into Z minus 1, okay, Z minus 1 all into what? This one like this. So here, if n is 1, if n is 1, I'll get what? A into what? Z minus 1. If n is 2, I'll get A into Z minus what? Sorry, here is minus 1 into what? 2. If n is, let's say, 3, if n is 3, I'll get what? A Z minus what? Minus 1 into what? 3. Okay. Plus what? It's going to what? Infinity. Okay. So basically here, let me rewrite this expression here. Okay, so this expression, what I have here is x of z is equal to what? A z minus 1 plus what? A z minus 1, okay, squared, plus a z minus 1 cube, plus what is going to infinity. Okay, so this is what I had. Okay, so now if I should bring something out, then a z minus 1 can come out. I'll have 1 plus a z minus 1. Okay, then I can have plus a z minus 1 what? Squared. Okay, plus is going to what? Infinity. So a z minus 1 into what? 1 plus x squared plus is going to what? Infinity. Okay, so now here az minus 1 into what? 1 minus what? X minus what? 1. So this is a Fourier expansion. That is going to give me this particular summation. So x of what? Z is going to be equal to this. So now here, x of z is going to be equal to what? Az minus 1 over what? 1 minus az minus 1, which is equal to, if I multiply through by z, what will I get? I'll get here to be what? A. I'll get here to be what? I'm multiplying through by z. Okay, I'll get here to be z. I'll get here to be what? Minus A. Okay, and what will be my ROC? Okay, so my ROC will be such that before this can go into convergence, it should be x should be less than 1. So x is what? Less than 1. Okay, so that means that A over Z is less than what? 1. So that means that Z is what? Or let me say A. Okay, A is less than what? A is less than Z, or Z is greater than what? A. All right. So here, my ROC is such that mod Z is greater than what? A. All right. So basically, that's how I can actually write this one. Okay. So combining my two solutions, I'm going to have x of z is equals to here my two solutions for a for my x of z, okay, which is equals to z of a mod what? N. Okay, I'm actually going to have combining my two solutions. Okay, I'm going to have minus z over z minus a, okay, plus a over z minus what? A. Okay, so this is what I'm going to have. And my ROCs, okay, my ROC for the first one, for this particular part, my ROC was what? Mod z is less than, okay, mod z is less than what? A. And for this particular part, I had mod z is greater than what? A. So let's say this is what? Mod z. Okay, so mod z is what? Less than A. Okay, it's less than A. So if A is here, okay, if A is here, here is greater than A. Okay, so it's greater than what? A. And here is less than what? A. So it's the what? Intersection within this what? Range. So this is my final what? ROC. So this is my final ROC. Okay, so this is how I believe you can solve this particular question. Okay, this is how you can solve this particular question. Thank you so much, and see you in the next lecture.